In May 1943, the secret weapon that broke German steel. In May 1943, the U.S. Army Ordnance Corps faced a crisis that threatened to cripple American armored forces before they even reached European shores. In a nondescript building at Aberdeen Proving Ground, Maryland, Colonel William Beasley stared at a report that made his blood run cold. German intelligence had confirmed what American tankers in North Africa were already learning the hard way. The new German Panther and Tiger tanks were virtually impervious to American tank guns. The mathematics of death were simple and brutal. The M4 Sherman's 75mm gun could penetrate 60mm of armor at 500 yards. The Panther's frontal armor was 100mm thick, sloped at 55 degrees, giving an effective thickness of 140mm. The Tiger's was 102mm of vertical steel. American shells didn't just fail to penetrate, they bounced off like tennis balls hitting concrete. "We're sending our boys to die in tin cans," Beasley muttered, pushing the report across his desk to Dr. Mohaupt, a Swiss-born physicist who'd been quietly recruited to the Aberdeen ballistics team. "We need a miracle, Doctor, and we need it fast." Mohaupt adjusted his wire-rimmed glasses, studying the penetration tables. "Colonel, miracles are for chaplains. What we need is better physics." That conversation would launch one of the most secret weapons programs of World War II, a project that would revolutionize armored warfare and create a weapon so devastating that German tank crews would come to believe the Americans had deployed some form of supernatural technology. They called it der Hexenschuss, the witch's shot. The Americans would know it simply as the HVAP round. The physics of desperation. The problem facing American engineers wasn't new. Since the invention of armor, military designers had engaged in an endless race between protection and penetration. Thicker armor demanded more powerful guns. More powerful guns demanded even thicker armor. By 1943, this cycle had reached a critical point where American tank guns simply couldn't keep pace with German armor development. Traditional armor-piercing rounds relied on mass and velocity. A heavy steel projectile, properly hardened and shaped, would punch through enemy armor through sheer kinetic force. But there were limits. Gun barrels could only withstand so much pressure. Projectiles could only be accelerated so fast, and steel, no matter how well crafted, had inherent limitations in its ability to penetrate other steel. Dr. Mohaupt had a different idea, one born from his work in civilian mining operations before the war. What if, he proposed to the gathered team of engineers and metallurgists, we stop thinking about punching through armor and start thinking about drilling through it? The concept was revolutionary. Instead of using hardened steel, Mohaupt proposed using tungsten carbide, a material so hard it was used to cut steel in industrial applications. Tungsten carbide had a density almost twice that of steel and maintained its hardness even at extreme temperatures. But there was a problem. Tungsten was rare, expensive, and difficult to work with. The entire U.S. strategic reserve of tungsten wouldn't be enough to supply conventional ammunition needs. "We don't need conventional ammunition," Mohaupt argued. "We need a few thousand rounds that can kill tigers and panthers. Quality over quantity." The team worked through the summer of 1943, developing what would become the HVAP, high-velocity armor-piercing round. The design was ingenious in its simplicity. A small tungsten carbide core, about the diameter of a pencil, was encased in a lightweight aluminum body called a sabot. When fired, the sabot would carry the tungsten penetrator down the barrel, then fall away, allowing the dense core to fly at unprecedented velocities, over 3,400 feet per second, nearly 3 times the speed of sound. But velocity was only part of the equation. When the tungsten penetrator struck armor at such speeds, the physics became almost alien. The kinetic energy of impact generated temperatures exceeding 200 degrees Celsius at the point of contact. The tungsten didn't melt. Its melting point was too high, but the steel armor around it did. The penetrator essentially drilled through the armor, creating a jet of superheated metal and gas that would spray into the tank's interior with devastating effect. Testing the impossible, September 1943, Aberdeen Proving Ground. The first live firing tests were conducted in absolute secrecy. A captured Panther tank, one of the few prizes from the North African campaign, sat 500 yards from the firing position. Its armor had already withstood dozens of conventional rounds during previous tests. The steel barely scarred by American shells. Master Sergeant Jake Thompson, a veteran tanker, pulled from the 1st Armored Division specifically for this test, sat in the gunner's position of a modified M4 Sherman. The new 76mm gun had been fitted with a special breech to handle the experimental ammunition. "Ready on the range," came the call from the tower. Thompson peered through his sight, centering the crosshairs on the Panther's hull. Beside him, Dr. Mohopt watched with a mixture of anticipation and dread. 3 years of theory were about to meet reality. "Fire!" The gun's report was sharper than usual, the recoil different. Thompson had fired thousands of rounds in training and combat, but this felt alien. Through the sight, he saw nothing. No explosion, no shower of sparks that usually accompanied a non-penetrating hit. "Did we miss?" he asked. "Let's find out," Mohopt replied, his voice tight with tension. The range was cleared, and the team approached the Panther. What they found defied their expectations. A perfectly round hole, no larger than a quarter, had been punched through the Panther's side armor. The edges of the hole glowed faintly, the metal still hot to the touch. But it was what they found inside that truly shocked them. The interior of the Panther looked like a blast furnace. Metal surfaces were discolored from extreme heat. The gunner's position, directly in line with the penetration, showed signs of flash burning. Instruments were melted, rubber seals vaporized. A mannequin placed in the commander's position for the test was charred beyond recognition, its clothing ignited by the superheated gases. "Jesus Christ," Thompson whispered. "It didn't just penetrate, it cremated everything inside." Dr. Mohopt was more clinical in his assessment, but no less impressed. The jet of molten metal and superheated gas expanded throughout the crew compartment in milliseconds. Temperature spike would be instantly lethal. Pressure wave would rupture organs. Secondary fires from ammunition and fuel would finish anything the initial penetration missed. Thompson stared at the hole, then at the doctor. "Doc, I've killed a lot of tanks, seen a lot of crews die, but this is different. This is like bringing hellfire itself, racing against time. By November 1943, the HVAP project had moved from experimental to critical priority. Intelligence reports from the Eastern Front described new German heavy tanks that made the Panther look like a light tank. The Tiger II, or King Tiger, boasted frontal armor over 180 millimeter thick. Conventional American ammunition would be useless against such monsters. Production faced enormous challenges. Each tungsten penetrator required precision machining to tolerances measured in thousandths of an inch. The aluminum sabots had to be perfectly balanced to ensure the round flew true after separation. A single flaw could cause the round to tumble, destroying accuracy and penetrating power. The tungsten itself was a strategic nightmare. The U.S. had limited domestic sources, relying heavily on imports from China and South America. Every pound used for ammunition meant less for critical machine tools and industrial applications. Bureaucratic battles raged as different departments fought for allocation. Lieutenant Colonel Marcus Webb, assigned to oversee production, found himself in the middle of these battles. In December 1943, he stood before the War Production Board, making his case. Gentlemen, I understand the competing needs for tungsten, but let me be clear. Without these rounds, our tank forces in Europe will be combat ineffective against German heavy armor. We're not asking for enough tungsten to arm every tank. We're asking for enough to give our boys a fighting chance. The board member from the Industrial Division pushed back. Colonel, you're asking for 15% of our total tungsten allocation for a weapon that's still experimental. What guarantee do we have that it will even work in combat? Webb placed a photograph on the table. It showed the interior of the test Panther, the devastating effects of the HVAP round clearly visible. This is what one round did to a Panther. Imagine what it could do to a Tiger. Imagine what not having it will cost us in American lives. The room fell silent. Finally, the board chairman spoke. You'll get your tungsten, Colonel. God help us if you're wrong. The first blood. The HVAP rounds, designated M93 for the 76 millimeter gun, first saw combat in limited numbers during the Italian campaign in early 1944. But it was during the Normandy invasion and subsequent breakout that they would truly prove their worth. Staff Sergeant Michael Hartley commanded a M4A1 76-ton W. Sherman in the 3rd Armored Division. His tank, nicknamed Widowmaker, was one of the first to receive a combat allocation of M93 rounds, 5 precious shells stored separately from the conventional ammunition. On July 11, 1944, near the village of Les Déserts, Hartley's platoon encountered their first Panthers in combat. The German tanks had taken position behind a stone wall, their long 75 millimeter guns covering the only approach to the village. 2 Shermans had already been knocked out attempting to flank the position. I see 2 Panthers, maybe 3, behind the wall, Hartley's driver, Corporal Anthony Russo, reported. Range about 600 yards. Hartley made a quick decision. Load HVAP. His loader, Private David Kim, carefully extracted one of the special rounds. The aluminum sabot gleamed in the dim light of the tank's interior. HVAP up! Through his periscope, Hartley could see the lead Panther's turret traversing toward them. In seconds, the German would have them in his sights. There was no time for careful aim, no time for ranging shots. It had to be perfect the first time. "On the way!" the Sherman's gun roared. Hartley watched the round's trajectory, saw it strike the Panther's hull just below the turret ring. For a heartbeat, nothing happened. Then smoke began pouring from the Panther's hatches, thick black smoke that spoke of internal fires. The Panther's turret hatch flew open. A figure tried to emerge, wreathed in flames, then fell back inside. The tank began to burn with an intensity Hartley had never seen before, like a furnace with its doors thrown wide. "Target destroyed," Kim reported, his voice shaky. "What the hell was in that round?" The second Panther, witnessing its companion's fate, began reversing rapidly. Its commander had seen enough. Whatever the Americans were firing, it wasn't worth facing. Hartley's crew would go on to destroy 6 German tanks with HVAP rounds during the Normandy campaign, earning Hartley a Silver Star. But in his letters home, censored by military authorities, he could only hint at what they'd witnessed. "We have something new," he wrote to his wife, "something that evens the odds. I can't say more, but for the first time since we landed, I feel like we have a real chance." The German response. By August 1944, German intelligence had identified the new American weapon as a critical threat. Captured rounds were sent to weapons testing facilities in Germany for analysis. What they found alarmed even veteran weapons designers. Dr. Ferdinand Porsche, designer of the Tiger and King Tiger tanks, personally examined the captured rounds. His report to the Wehrmacht High Command was stark. "The Americans have developed a kinetic penetrator using tungsten carbide that renders our current armor schemes obsolete. The velocity achieved creates penetration mechanisms we have only theorized about. Impact temperatures exceed the melting point of steel. Our heaviest armor provides only marginal additional protection." The psychological impact on German tank crews was even more severe than the technical challenge. Panzer units that had operated with near impunity now faced a weapon that negated their primary advantage. Tank commanders who had grown accustomed to American shells bouncing harmlessly off their armor now lived in constant fear of the telltale sharp crack that preceded destruction. SS Unterscharführer Wilhelm Bauer, a Tiger tank commander in the 2nd SS Panzer Division, recorded in his diary, August 23, 1944, "Lost 3 Panthers today to American tanks. Single shots, all 3. Weber's tank was hit at 900 meters. Impossible range for normal ammunition. The crew had no chance. The Americans have some new devil weapon. The men are calling it the witch's shot. Morale is breaking." German countermeasures were hastily implemented. Additional armor plates were welded to vulnerable areas. Tanks were instructed to maintain maximum range from American forces. Some crews even resorted to improvised protection, sandbags, concrete, anything that might disrupt the tungsten penetrator's terrible efficiency. None of it worked. The HVAP rounds were designed to defeat armor through velocity and density, not just raw power. Additional armor plates only marginally decreased penetration while significantly hampering mobility. The sandbags and concrete were useless against tungsten traveling at 3 times the speed of sound. The Battle of Aricourt, September 1944. The Battle of Aricourt would become the largest tank battle on the Western Front and the proving ground for American tank tactics built around the HVAP advantage. The German 5th Panzer Army, equipped with new Panthers straight from the factory, launched a massive counter-offensive aimed at stopping Patton's Third Army. Over 200 German tanks faced off against the 4th Armored Division's 150 Shermans. On paper, it should have been a German victory. The Panthers outgunned and out-armored the Shermans in every conventional metric. But the Americans had two advantages: tactical air support and crates of M93 HVAP ammunition rushed forward from supply depots. Captain William Marshall commanded a company of M4A1 76W Shermans during the battle. His after-action report provides a vivid account of how HVAP rounds changed armored combat. September 19th, 0630 hours. German armor advancing across open ground. Counted 20-plus Panthers in first wave. Ordered all tanks to load HVAP and hold fire until 800 yards. Germans confident, advancing in parade formation. They expected another turkey shoot. 0645 hours. Opened fire at 750 yards. First volley destroyed 6 Panthers instantly. Never seen anything like it. Clean penetrations, internal fires immediate. German formation faltered, confused. They couldn't understand how we were killing them at range. 0700 hours. Germans attempted to retreat, pursued, destroying 8 more tanks. HVAP rounds effective even on rear shots at extreme angles. Panther armor might as well have been cardboard. The 3-day battle saw the destruction of over 80 German tanks for the loss of 25 American vehicles. More importantly, it shattered the myth of German armored superiority. Tank crews that had advanced confidently now approached every engagement with dread. A captured German tank officer later told interrogators, "We knew the Americans had developed something new. Our intelligence called it a tungsten weapon, but we didn't understand until Aracourt. They could kill us at ranges where we couldn't kill them. They could penetrate armor that should have been impenetrable. It wasn't war anymore. It was execution." The Winter of Fear. The German Ardennes offensive in December 1944, the Battle of the Bulge, would put HVAP technology to its ultimate test. Hitler had assembled his last reserves of armor, including the newest King Tiger tanks with frontal armor that was theoretically impervious to any Allied weapon. Theoretically. Private First Class Robert Chen was a loader in an M36 tank destroyer equipped with a 90mm gun and the new M304 HVAP rounds, an even more powerful version designed specifically for the heaviest German armor. On December 18, 1944, his vehicle encountered a King Tiger near the village of Stoumont. It came out of the morning fog like a metal mountain, Chen recalled years later. Our commander whispered King Tiger like he was announcing the Angel of Death. Its gun was bigger than anything I'd ever seen. One shot from that 88 and we'd be vapor. The tank destroyer's gunner, Sergeant Thomas Anderson, remained calm. Range? 400 yards and closing. Load HVAP. Chen's hands moved automatically, pulling the long, slim round from its special storage. The aluminum sabot felt alien compared to regular shells, lighter, but somehow more lethal. Up! The King Tiger's turret was traversing toward them, the massive 88mm gun swinging like doom itself. Anderson fired first. The 90mm gun's report was deafening in the confined space. Through the commander's periscope, they watched the round strike the King Tiger's frontal plate. 185 mm of the finest armor steel Germany could produce. It punched through like it wasn't there. The King Tiger stopped as if it had hit an invisible wall. For several seconds, nothing happened. Then every hatch blew open simultaneously, vomiting smoke and flame. The internal ammunition had cooked off in a chain reaction, turning the tank's interior into a crematorium. "Holy Mother of God," Chen whispered. "We just killed a King Tiger with one shot." The crew watched in horrified fascination as the massive tank burned. The armor that should have been impenetrable had failed catastrophically. The psychological impact rippled through both armies. American crews gained confidence, while German tankers lost their last illusion of invincibility. The science of terror. To understand why HVAP rounds created such fear among German tank crews, one must understand the physics of what happened in the milliseconds after impact. When tungsten carbide traveling at 3,400 feet per second strikes steel armor, the interaction transcends conventional ballistics. The kinetic energy of the impact, roughly 2.5 million joules for a 76 mm HVAP round, concentrates on an area smaller than a coin. The pressure at the point of impact exceeds 100,000 atmospheres. Steel doesn't just break or tear, it flows like liquid. The tungsten penetrator, maintaining its integrity due to its extreme hardness and high melting point, pushes through this liquefied steel like a hot needle through wax. But the penetrator isn't the only thing entering the tank. The liquefied steel, now at temperatures exceeding 200 degrees, jets ahead of and around the tungsten core. This jet of superheated metal plasma expands violently in the crew compartment. The pressure wave alone can be lethal. Human bodies subjected to such rapid pressure changes suffer catastrophic injuries. Lungs collapse, eardrums rupture, internal organs hemorrhage. Then comes the thermal effect. The metal jet and superheated gases raise the temperature inside the tank by hundreds of degrees in fractions of a second. Clothing ignites. Exposed skin suffers third-degree burns instantly, and ammunition begins cooking off in a deadly chain reaction. Dr. Klaus Zimmermann, a German physicist who studied captured HVAP rounds after the war, described it clinically. The Americans had weaponized thermodynamics itself. They turned our tanks from protective shells into pressure cookers. A crew hit by HVAP didn't die from shrapnel or explosion in the traditional sense. They died from physics, pressure, heat, and the violent transformation of their own armor into the instrument of their destruction. Production crisis and innovation. By late 1944, demand for HVAP ammunition far exceeded supply. Frontline units hoarded their allocations, using them only against the heaviest German armor. Tank commanders would sometimes refuse to engage Panthers with conventional rounds, waiting for units with HVAP to arrive. The bottleneck was tungsten. China, America's primary supplier, was barely maintaining its supply lines through Japanese-occupied territory. South American sources were limited and expensive. The War Department faced an impossible choice: reduce HVAP production or find new sources. The solution came from an unexpected source. Dr. Sarah Mitchell, one of the few female scientists in the Aberdeen ballistics program, proposed recycling tungsten from worn machine tools and industrial waste. Every factory in America has tungsten carbide cutting tools that are replaced when worn, she argued. That waste tungsten could make thousands of HVAP rounds. A nationwide collection program was hastily organized. Factory workers who had been building tanks and aircraft now contributed in a different way, collecting worn tungsten tools for recycling. The program's slogan, "Your worn tools kill tigers," became a rallying cry in defense plants. By January 1945, recycled tungsten was supplying 30% of HVAP production needs. Combined with improved manufacturing techniques that reduced waste, production increased from 1,000 rounds per week to over 5,000. The Rhine crossing, March 1945. The Western Allies stood on the west bank of the Rhine, Germany's last major natural barrier. On the opposite shore, German forces had assembled their final reserves of armor, including the newest Tiger II tanks and Tiger tank destroyers with armor up to 250 millimeter thick. Operation Plunder, the assault across the Rhine, would test whether HVAP technology could overcome the most heavily armored vehicles ever built. Among the assault forces was the 9th Armored Division, equipped with new M96 Pershing tanks and ample supplies of T-30E16 HVAP rounds for their 90mm guns. Staff Sergeant James Washington commanded one of these Pershings. An African-American tanker from Detroit, Washington had fought through France and Belgium, earning a reputation for calm under fire and deadly accuracy. His gunner, Corporal Hispanic Martinez from El Paso, was considered one of the best in the division. On March 24th, as American forces established their first bridgeheads, Washington's platoon encountered a position defended by two Tigers, massive tank destroyers with frontal armor that German propaganda claimed was absolutely impenetrable. "I see them," Martinez reported. "Range 1,100 yards. They're hull down behind a railway embankment. Only the superstructures are visible." Washington studied the position through his periscope. The Tigers' 120mm guns could destroy his Pershing at twice this range. But they had one advantage. The Germans didn't know the Americans had HVAP rounds that could penetrate even their massive armor. "Load HVAP. Target the one on the left." The special round slid into the breech with a distinctive metallic ring. Martinez made minute adjustments to his aim, accounting for range and the slight crosswind. "On the way." The round crossed the distance in less than a second. Washington watched it strike the Tiger's superstructure right where the armor was thickest. 250 mm of specially hardened steel. The tungsten penetrator drilled through. The effect was immediate and catastrophic. The Tiger's hatches burst open, fountaining smoke and flame. Secondary explosions rippled through the vehicle as ammunition cooked off. The second Tiger, witnessing its companion's destruction, attempted to reverse, but exposed its thinner side armor. Martinez's second HVAP round caught it squarely, penetrating the 80mm side plate like tissue paper. "Two Tigers, 2 shots," Washington reported over the radio. "Path is clear." The destruction of the impenetrable Tigers spread through both armies like wildfire. German crews abandoned positions rather than face American tanks. Some crews even scuttled their own vehicles, claiming mechanical failures rather than admit they were afraid to fight. The human cost. For all its technical excellence, the HVAP round extracted a psychological toll on both sides. American tankers who had used them reported lasting trauma from witnessing their effects. The clean, almost surgical penetrations belied the horror that occurred inside enemy tanks. Sergeant Michael O'Brien, a Sherman commander who survived the entire European campaign, struggled to articulate his feelings in a 1946 interview. With regular shells, when you knocked out a tank, the crew usually had a chance. They could bail out, surrender, survive. With HVAP, there often wasn't anyone left to surrender, just silence and smoke. I know they were the enemy, but Christ, what a way to go, cooked alive in a steel box. German survivors told even more harrowing tales. Feldwebel Hans Müller, one of the few Panthers commanders to survive an HVAP hit, described his experience. The round came through the turret side. I didn't hear it, didn't see it. Just suddenly, the air turned to fire. My loader simply ceased to exist. One moment he was there, the next he was ash and shadow burned into the turret wall. My gunner's uniform ignited instantly. I managed to pull him out, but his burns, the medic said it was like he'd been dipped in molten metal. The psychological impact extended beyond individual trauma. Entire German armored units began showing signs of combat ineffectiveness, not from losses, but from fear of engagement. The SS Panzer divisions, elite units that had never shown fear on the Eastern Front, began reporting increasing numbers of mechanical failures that prevented tanks from advancing. One captured SS officer admitted under interrogation, "My men would rather face Russian artillery barrages than American tanks with those devil rounds. At least with artillery, you might survive. With the witch's shot, there was only death." Industrial aftermath. As the war in Europe ended in May 1945, the full impact of HVAP technology became clear. In just 18 months of combat use, HVAP rounds had destroyed over 2,000 German tanks and armored vehicles, forced fundamental changes in German tactical doctrine, accelerated the collapse of German resistance by months, saved an estimated 10,000 Allied tank crew lives. The technology had proven so effective that captured German documents revealed plans for their own tungsten ammunition program, abandoned only due to lack of raw materials and industrial capacity. But the real revolution was just beginning. The principles demonstrated by HVAP rounds using exotic materials and hypervelocity to defeat armor would reshape military technology for generations. Every modern tank-killing weapon, from the depleted uranium rounds used in Desert Storm to the latest anti-tank missiles, owes its conceptual design to those first tungsten penetrators. The secret spreads. Despite attempts at security, knowledge of HVAP technology quickly spread among Allied nations. The British developed their own version, the APDS, armor-piercing, discarding Saba round, based on captured German reports about American ammunition. The Soviets, through both espionage and official channels, acquired HVAP technology and began their own development programs. By 1950, tungsten-cored ammunition had become standard in most major militaries. The Korean War saw Chinese T-34 tanks destroyed by HVAP rounds fired from World War II-era American tanks, proving the technology's enduring effectiveness. The nuclear age brought new materials. Depleted uranium offered even greater density than tungsten. But the fundamental concept remained unchanged. Hypervelocity, super-dense penetrators defeating armor through kinetic energy and thermodynamic effects. Legacy of fear. Veterans of the European theater carried stories of HVAP rounds for the rest of their lives. Reunions of the 3rd Armored Division featured informal competitions about who had made the longest-range HVAP kill. German veterans, when they began attending joint reconciliation events in the 1960s, spoke with awe about the Hexenschuss that had broken their seemingly invincible panzers. In 1985, at a gathering of American and German tank veterans in Munich, former SS Hauptsturmführer Erich Hoffmann met Michael Hartley, the American sergeant who had destroyed his company's lead Panther in Normandy. Their conversation, recorded by a historian present at the event, captures the lasting impact. Hoffmann: "We called you the Burning Death. One shot, one funeral pyre. My men were terrified." Hartley: "We were terrified too. Of your 88s, your armor. The HVAP rounds just evened the odds." Hoffmann: "Evened? No, Sergeant. They ended the illusion that armor could protect us. After Normandy, we knew we were just driving coffins." The two veterans, former enemies, shared a drink in memory of crews on both sides who didn't survive the catastrophic meeting of tungsten and steel. Technical evolution. Post-war analysis of HVAP technology led to continuous improvements. The original M93 rounds achieved roughly 50% penetration increase over conventional ammunition. By the 1960s, improved designs were achieving 200% increases. Modern variants can penetrate over a meter of rolled homogeneous armor. The technology also influenced civilian applications. Tungsten carbide cutting tools, mining equipment, and industrial processes all benefited from research originally conducted for HVAP rounds. The precise metallurgy required for consistent penetrator performance advanced material science by decades. Dr. Robert Chen, who had been Private Chen, the loader, in 1944, became a material scientist after the war. His research into tungsten carbide behavior under extreme stress, informed by his combat experience, led to breakthroughs in industrial applications. "Every time I see a tungsten carbide drill bit," he noted in a 1990 interview, "I remember loading those rounds." Death became technology, became progress. It's a strange world. The moral equation. The effectiveness of HVAP rounds raised uncomfortable questions about the nature of military innovation. The rounds were undeniably effective, saving Allied lives and shortening the war, but they also represented a new level of lethality, turning tank combat from dangerous duty into near-certain death for those on the receiving end. Military ethicists have long debated whether HVAP rounds represented a qualitative change in warfare. Professor Sarah Williams of West Point argued in a 2010 paper, the HVAP round fundamentally altered the tank crew's relationship with their vehicle. Previously, armor provided protection, a chance of survival. HVAP technology turned that armor into a trap, ensuring that penetration meant annihilation. It was not just a better weapon, but a different category of weapon, one that killed through physics rather than fragmentation. Veterans struggled with similar questions. Many American tankers reported feeling guilty about the devastating effectiveness of HVAP rounds, even as they recognized their necessity. The clean penetration holes belied the inferno within, creating a disconnect between action and consequence that troubled many. Conclusion: the longest shadow. Today, tungsten penetrators are standard equipment in every major military. The technology that seemed like witchcraft in 1944 is now routine. Tank crews trained to fight and survive in an environment where any opponent might possess rounds capable of turning their armor into molten death. The M93 HVAP round and its descendants represent more than military innovation. They symbolize the moment when warfare entered the age of material science, when victory became a function of who could better manipulate matter at the molecular level. The German Tiger tank, with its massive armor and powerful gun, represented the apex of traditional tank design. The HVAP round proved that tradition was obsolete. In military museums across the world, HVAP rounds are displayed with clinical detachment, small, unassuming projectiles that changed history. Visitors rarely understand what they're looking at. The tungsten cores look like oversized pencils, the aluminum sabots like toys. But veterans know. They remember the sharp crack of impact, the sudden silence from a struck tank, the smoke pouring from hatches that would never open again. The last surviving tank commanders from World War II are few now, their memories fading like old photographs. But in their nightmares, some still hear it. The distinctive sound of tungsten meeting steel, the herald of physics weaponized. They remember when American science broke German steel, not through overwhelming force, but through elegant application of materials and velocity. The witch's shot, the burning death, the hot shot, different names for the same phenomenon. The moment when human ingenuity found a new way to kill, and in doing so saved countless lives by ending a war months sooner than otherwise possible. That is the paradox of military innovation, written in tungsten and measured in lives saved and lost. The HVAP round killed with unprecedented efficiency, and in that efficiency found a terrible mercy. Wars end quicker when the tools of war become too effective to endure. In May 1943, Colonel Beasley had asked for a miracle. What he got was something more powerful. Physics deployed with lethal precision. The ghost of every Tiger and Panther destroyed by HVAP rounds stands as testimony to a simple truth. In war, technology triumphs over courage, science over steel, and tungsten, properly applied, over everything else. The rounds that seemed like witchcraft were simply humanity's latest answer to an ancient question: how to defeat an enemy's strength. The answer, written in the language of velocity and thermodynamics, echoes still in every modern battlefield where kinetic energy meets armor and armor loses. That is the legacy of the hotshot, not just a weapon, but a paradigm shift. The moment when tank warfare entered the modern age and metal titans learned they could be slain by something no larger than a pencil, moving faster than sound, carrying death in the form of pure physics. The witch's shot had broken more than German armor. It had broken the very concept of armored invulnerability, forever changing how humanity would wage mechanized war. In the end, tungsten carbide at 3,400 feet per second proved more powerful than all the forges of the Reich. And somewhere in a museum, a small tungsten penetrator sits silent in its case, looking like nothing more than a metal rod, giving no hint of the inferno it could create, the physics it could unleash, the history it had written in fire and fear across the battlefields of Europe. The Final Testament. In 2019, the last known combat veteran who had fired HVAP rounds in World War II passed away. Master Sergeant Michael Hartley died peacefully in his sleep at age 97, surrounded by family at his home in Pennsylvania. His obituary in the local paper mentioned his Silver Star and Bronze Star, his service with the 3rd Armored Division, but not the revolutionary weapon he had helped prove in combat. His grandson, David Hartley, a professor of military history at Penn State, discovered something remarkable while going through his grandfather's effects. In a cigar box marked "Not to be opened until after my death," he found 5 items: Hartley's Silver Star, a photograph of his Sherman crew, a small piece of metal, a German Iron Cross, and a letter dated '94. The piece of metal was a spent tungsten penetrator, its tip slightly deformed from impact. The letter explained its significance. "To whoever finds this is the core from the first HVAP round I fired in combat. July 11th, 1944, Le Désert, France. We dug it out of a knocked-out Panther 3 days later. I've carried it for 50 years as a reminder. The Iron Cross belonged to the commander of that Panther. I met him in 1994 at a veterans reunion in Normandy. Hans Richter survived the war, one of the few from his unit. He gave me his medal, and I gave him my unit patch. We talked for hours about that day, about the war, about what came after. He told me something I'll never forget. Your shot didn't just destroy my tank, it destroyed my faith in the war. We thought our armor made us invincible. When I saw what your round did to my friend's Panther, I knew we had lost. Not just the battle, but the war. You can't fight physics." I've thought about that conversation every day since. We created something terrible with those tungsten rounds. Necessary, but terrible. They saved lives by ending lives more efficiently. That's the devil's arithmetic of war. If you're reading this, I'm gone. Do something good with this knowledge. Remind people that every military innovation has a human cost, paid in blood and measured in nightmares. The tungsten killed clean, but memory is messy. Tell them about Hans Richter and his crew. Tell them about my crew, Russo, Kim, Patterson, and Johnson. Tell them we were all just boys trying to survive, using whatever tools we were given. The HVAP rounds were just tools. Terrible, efficient tools, but tools nonetheless. The real weapons were fear and courage, duty and desperation. The tungsten just made the killing quicker. MSG Michael Hartley, 3rd Armored Division, 1944 to 1945. David Hartley donated the penetrator and letter to the U.S. Army Heritage and Education Center at Carlisle, Pennsylvania. They became part of a special exhibit on tank warfare innovation, displayed alongside technical drawings, combat reports, and photographs of both American and German tank crews. The engineering legacy. The HVAP principle, using kinetic energy and material properties rather than explosive force, revolutionized not just military technology, but our understanding of material science. By 2020, descendants of HVAP technology included depleted uranium penetrators capable of defeating any known armor, electromagnetic railguns firing tungsten projectiles at 7 times the speed of sound, orbital kinetic bombardment concepts using tungsten rods as rods from God, industrial cutting tools that could slice through materials once thought impossible to machine. Dr. Jennifer Martinez, great-granddaughter of Corporal Martinez, who had been Hartley's gunner, became a materials engineer specializing in armor development. In a 2021 lecture at MIT, she reflected on the ironic cycle. My great-grandfather used tungsten to destroy German armor. I use ceramics and composites to defeat tungsten. It's an endless race between sword and shield, but now we fight with atomic structures and crystalline matrices instead of just thick steel. The HVAP round taught us that brute force is less important than understanding the deep physics of materials. Every modern tank's composite armor exists because of lessons learned from tungsten penetrators. The museums remember. At the Deutsches Panzer Museum in Munster, Germany, a Panther tank sits with a small perfect hole in its side armor. A placard in German and English reads, "This Panther was destroyed near Aracourt, September 1944, by a single American HVAP round. The crew did not survive." This exhibit honors all tank crews who faced the terrible evolution of anti-tank warfare. The hole, you see, represents not just a technical innovation, but the moment when traditional armored warfare ended and modern materials science began. Visitors often miss the small exhibit at first, drawn instead to the impressive Tiger and King Tiger displays. But veterans and their families seek it out, leaving flowers and unit patches from both Allied and Axis forces. The guest book contains thousands of entries in dozens of languages, many simply reading, "We remember." At Aberdeen Proving Ground, now the U.S. Army Aberdeen Test Center, Building 310, where Dr. Mohopt and his team developed the HVAP round, has been preserved as a historical site. Tours are given monthly, showing the original testing facilities and early prototypes. The guide, often a young soldier from the Ordnance Corps, explains the physics with practiced ease, but always ends with a reminder. These rounds saved American lives and helped end the war faster, but they also represent the constant evolution of warfare. Today's soldiers face threats the HVAP designers never imagined, just as German tankers never imagined tungsten traveling at 3 times the speed of sound. Innovation in warfare is constant, and so must be our vigilance. The Last Echo. On June 6, 2024, the 80th anniversary of D-Day, the last gathering of World War II tank veterans took place at Normandy. Only 17 men attended, the youngest being 98. Among them was James Washington, the African-American tank commander who had destroyed the Jag Tigers at the Rhine. In his wheelchair, wearing his original tanker's jacket covered in unit patches and medals, Washington was asked by a young historian about the HVAP rounds. "Young man," Washington said, his voice still clear despite his age, "we didn't think about the science. We knew they worked. 1 shot, 1 kill, most times. But I want you to understand something. Every tank we killed had men inside. Boys, really. German, American. didn't matter much in the end. They all had mothers who cried for them. He paused, looking out toward Omaha Beach. The HVAP rounds. They were mercy in a way. Quick, cleaner than burning alive from a regular hit. If you had to go, better from one of those than bleeding out in a burning Sherman. That's what I tell myself anyway. The historian asked if he had any regrets about using such a devastating weapon. Washington's answer came slowly. Regrets? Son, war is nothing but regrets dressed up in necessity. But if those tungsten rounds got even one more American boy home to his family, then they were worth it. That's the only math that mattered to us. The technical twilight. As of 2024, tungsten-core kinetic penetrators remain a staple of military arsenals worldwide, though the technology has evolved far beyond the simple M93 rounds of 1944. Modern variants include self-sharpening depleted uranium penetrators that maintain their point during penetration, segmented tungsten rods that create multiple penetration channels, smart penetrators with microsensors that optimize penetration angle in flight, hybrid rounds combining kinetic and explosive effects. Yet the fundamental principle discovered at Aberdeen Proving Ground remains unchanged. Density plus velocity equals penetration. Every advancement is merely a refinement of what Dr. Mohopt and his team proved in 1943. The cost has changed dramatically. Where each HVAP round in 1944 cost more than a soldier's monthly pay, modern tungsten ammunition is mass-produced with computerized precision. What was once a strategic resource hoarded for critical engagements is now standard issue for most main battle tanks. But veterans of the Tungsten Revolution, as military historians now call it, remember when each round was precious, when tank commanders would rather risk conventional ammunition than waste an HVAP shot on anything less than heavy armor. Final accounting military statisticians have attempted to quantify the impact of HVAP technology on World War II's outcome. Their conclusions: HVAP rounds shortened the European war by an estimated 3 to 4 months, saved approximately 50,000 to 75,000 Allied casualties, destroyed over 2,000 German armored vehicles that would have otherwise required multiple conventional hits, forced German tactical changes that reduced their armored forces' effectiveness by an estimated 40%. But statistics cannot capture the human dimension. They cannot quantify the terror of a Panther crew seeing their company commander's tank destroyed by a single shot. They cannot measure the relief of a Sherman gunner knowing he has 5 HVAP rounds that can save his crew's lives. They cannot weigh the nightmares that haunted men on both sides who witnessed tungsten's terrible efficiency. The eternal question. Professor Sarah Williams, in her final lecture before retirement from West Point in 2023, posed a question that echoes through the decades since HVAP's introduction. Was the HVAP round a technological triumph or a moral compromise? It killed more efficiently, which in military terms meant saving Allied lives. But it also introduced a level of lethality that turned tanks from fighting vehicles into crematoriums. There is no clean answer, only the recognition that in war, every innovation carries both salvation and damnation. She concluded with a story from her own grandfather, who had commanded a Sherman equipped with HVAP rounds. He told me that after the war, he became a firefighter, said he'd spent enough time turning steel into ovens, wanted to spend the rest of his life pulling people out of burning buildings instead of putting them in. That's the weight these men carried, not just the memory of combat, but the knowledge of what their weapons did to other human beings. The Monument. In 2025, a joint American-German commission unveiled a monument at the former Aberdeen Proving Ground. Made of tungsten and steel, it consists of a penetrator suspended in midair, passing through a steel plate that never quite touches either side, frozen forever in the moment of impact. The inscription, in English and German, reads, "To all who faced the evolution of warfare with courage, to the scientists who created, the soldiers who employed, and the enemies who endured the tungsten revolution. May future generations learn that innovation in war, however necessary, always carries a human cost." 1944 to 1945. At the dedication, the last surviving HVAP gunner, 102-year-old David Kim, was helped to the podium. His prepared remarks were brief. "I loaded the rounds, Hartley fired them. German boys died, American boys lived. That's war reduced to its simplest equation. The tungsten was just the variable that made our side of the equation work out better. I pray nobody ever has to solve such equations again." The crowd, military officials, historians, families of veterans from both sides, stood in silence as Kim was helped back to his wheelchair. In that silence lay the weight of innovation, the cost of progress, the price of survival. Epilogue: The Wisdom of Tungsten. The story of the HVAP round is more than military history. It's a meditation on human ingenuity applied to destruction, on the thin line between technological triumph and moral complexity. It reminds us that every advance in military technology is ultimately about young men and women facing death with whatever tools their nations can provide. Today, as military planners contemplate hypersonic missiles, directed energy weapons, and autonomous killing machines, the lessons of the HVAP round remain relevant. Technology can provide tactical advantage, can save lives through superior lethality, but it cannot remove the human element from war. Inside every tank destroyed by tungsten were human beings, with families, dreams, and fears identical to those who fired the rounds. The tungsten penetrators in museums around the world stand as silent testimony to this truth. They are remarkably small objects to have changed history so dramatically. No larger than a pencil, no heavier than a paperweight. Yet they ended an era of armored warfare and began another, proved that material science could trump traditional military virtues, and showed that in modern war, understanding physics might be more important than understanding tactics. The German tankers called them Hexenschuss, the witch's shot, because they seemed to defy natural law. But they were the opposite of magic. They were pure science, applied with lethal precision. In their terrible efficiency lay both their tactical value and their moral burden. As we move forward into an age of even more sophisticated weapons, the HVAP story offers a crucial reminder. Every military innovation has consequences beyond the battlefield. The tungsten rounds that saved Allied lives also created new nightmares, new ways for young men to die in steel coffins. They shortened the war but lengthened the shadow it cast over those who survived. In the end, perhaps that is the most important lesson of the tungsten revolution, that in war, every problem solved creates new problems. Every life saved through superior technology is balanced by lives lost to that same technology, and every innovation carries within it both liberation and damnation. The HVAP round broke German steel, but it also broke something more fundamental: the illusion that armor could provide true protection, that technology could make war survivable, rather than just changing the methods of dying. In that perfect, terrible hole punched through a Panther's armor lies a truth as relevant today as it was in 1944. In the face of human ingenuity applied to destruction, there is no perfect defense, only the hope that wisdom might someday outpace our ability to kill. The hot shot had cooled, but its lesson burns eternal. We are capable of creating weapons that exceed our wisdom to use them, and in that gap between capability and wisdom lies the true battlefield of the human condition. In May 1943, the U.S. Army had asked for a miracle. What they got was tungsten at 300-400 feet per second. Whether that was miracle or curse depends, perhaps, on which end of the gun you stood. But for the men who made it home because of those small metal penetrators, and for the families who welcomed them back, the answer was clear enough. The witch's shot had done its work. The war was won. The reckoning with what that victory cost in human terms would take a lifetime to calculate, and even then, the equations would never quite balance. They never do in war. That's the final lesson of the HVAP round, that in conflict, victory and tragedy are not opposites, but aspects of the same terrible truth. The tungsten sleeps now in museums and memories, its work long done. But its legacy lives on in every modern battlefield, every materials laboratory, every calculation of how to make warfare more efficient. It reminds us that we are very good at solving the technical problems of war. Whether we're equally good at solving the human problems that create wars in the first place remains an open question, one that no amount of tungsten traveling at any velocity can answer. Please support this video with the like and subscribe to the channel if you enjoyed it. Goodbye, and see you all soon.